Welcome to the first section in our CAE class. This section will be focused on creating internal fluid volumes and also external fluid volumes. So to start, we're going to open up a part in your analysis design session folder. It should be volume extract. So we'll double click on fluidflow.scdoc. So we have our model here, and we're going to extract the fluid from inside of it by going to our Prepare tab. This is where we have our Fluid Extract tool. And if we click on that, we'll need to select our edge loops that define an enclosed region. So I'm going to select an inlet, and I'm going to select our outlet. Now if I think I have all the loops I need selected, I'll click the check mark. Now it failed to create that volume because it said cannot create a volume body, all ends have not been capped. So I thought that the volume just ran through this center, but it's hard to see what's going on inside of our part. So I'm going to go to our Design tab, go to Select, and it's usually a useful practice to look at this in a cross section. So I'm going to click on our axis running through our part and click on the Section Mode button. It's between Sketch and 3D. So by selecting on that, I can see that the reason I didn't have all our ends capped was that the fluid came in through this end and went out through all of these other tabs and openings. So I really want to enclose that. And it could have happened during the initial design, someone could have made a mistake, but I want to correct that here. So I'll go to our Pull tool, and remember in 2D, or in a cross section, what looks like an edge actually represents a face. So I can pull that in either direction to make a change. I can even pull that up to, using our up to button, this face here. So now I have a watertight fit. So if I zoom out, I'll go to our 3D mode. Now I'll go back to our Prepare tab so I can extract that volume. Volume extract, our inlet, and our outlet, and I'll click the check mark. That will generate our fluid body. And you'll notice another component is created in the structure tree as well. Now the interesting thing about fluid volumes and fluid extractions that I create, I go to the Pull tool. Let's say we pull on this end and even change the inner radius here. So we've made a change to our outer solid. If you right click on volume, you'll be able to update the volume body as it was created. It'll use those same inlets and outlets that I defined and recreate that body for you. So if you're ever making design changes, it's always a good idea to update the volume before you send it back to your analysis tool. Now the other thing we'll look at are creating external fluid bodies. And for that we're going to use our enclosure tool. So that creates an enclosure around selected objects. So I'm going to select all the bodies on screen by box selecting them. And now I'll create an enclosure. You'll notice that it starts to create a transparent body around all of those solids. You can determine what cushion you'd like in our options. So I can make that a little bit bigger. Or I can always type in values into these boxes. You can define it with a cylinder, a sphere, or a box. Now if it turns out that your enclosure body is not oriented in the right direction or the direction you anticipated, you can always use our Set Orientation tool guide. If I click on that, I can set the orientation. So I'll click on any of these lines to orient our cylinder along that line. And once I'm ready, I'll click the check mark to generate that body. Now you'll notice that we now have a volume body and our enclosure. If I hide the other components, we can zoom in and see those two bodies. We see the internal volume I created, which is the volume component, and we can see the enclosure body I created, which is the outer solid. So thank you for watching this section on volume creation. I hope you've seen both how to create an internal volume by capping the edges, and also how to create an external volume by choosing which volumes you'd like to include in the enclosure. Thank you for watching. Hello, and welcome to the second session of our CAE class. Here we'll be focusing on interference detection, imprinting faces, and removing rounds. To start with, I'm going to go to the upper left-hand corner and open up our file. So in your analysis design session folder, we should have a folder for interference and imprint. I'm going to open up top level assembly. Now the first thing we're going to do is to go to the Prepare tab. This is where we'll be able to find and detect interferences on the model, and I'm going to use the interference tool to do so. If I click the tool, you'll notice it detects interferences that are on our part, and we can see them highlighted in red. Now oftentimes, to make it easier to see what the interferences look like, I'll go to our Design tab, select on an axis of one of our parts so that I can go into a cross-section. So cross-section is between 3D mode and sketch mode. That'll help me better see how the parts are interfering with each other, because I want to talk to you about what happens when we're in the Prepare tab and we remove the interference. So here we can see again, the areas are highlighted in red. It says we have two interfering regions. And when I click one of the red areas, you'll notice that the area is removed from the larger of the two solids. Now sometimes this could be what you want, but other times with this bearing, if we click the red area, you'll notice that geometry is taken out of our darker blue solid, which isn't really what we wanted. So I'm going to undo. Instead, show you how we can use the interference tool to detect interferences, but then go back to design and use our tools here to address them in different ways. For example, with pull, we could select on this face and pull it in either direction. Notice that's one way I can get rid of that interference. And if I wanted to make them coincident, I would pull our first face up to the second one. And that snaps those two faces together. So if I go back to 3D and go to Prepare and click on the Interference button, you'll notice that there's no interfering bodies. Now let's move on to Imprint. Because let's say we want to set up a good mesh between our bodies. So we want to have the faces the same size on each part. Now, if we're using ANSYS, you can always use shared topology and just set that here. But we will go into more detail with that in the ANSYS class. For anyone else who's using other programs, it'll be important to know how we can use Imprint. For example, here you see this orange face is one single face. If I run the Imprint tool, it'll go through and detect areas that can be imprinted. So notice this edge of the blue solid will be imprinted onto the orange one when I click it. So now if I was to right click on this solid and hide it, you can see that that face has now been split into two regions. So if I show all again, run the Imprint tool, you'll notice you can fix these one at a time, or you can click on the check mark and fix those 6 coincident faces at the same time. So now if I were to hide this inner bearing, it's now imprinted all those faces. An imprint is a great way for you to apply a similar mesh on both solids. Now the last thing we're going to look at in our Prepare tab is the Rounds tool. What the Rounds tool does is helps you to only filter rounds into your selection. So for example, it can make it easier to double click on round chains and click the check mark to remove them. But the round tool has another use, because here you'll see an area where a lot of rounds are coming together which could be difficult to remove. So if I select on all of those rounds to get rid of, and I'm double clicking to select the round chain, when I click the check mark and try to remove that from the model, nothing happens. And you notice that the little hourglass is ticking away. So anytime it takes a little bit of time, I usually hit the escape key to cancel that. Because instead I'll show you the second thing the round tool does. And notice when I hover over the edge, those two purple lines appear. That helps me split that round into two pieces. And it's using this cap width to determine how much. If I switch that to 20, it's going to be much smaller. If we switch that to 60, it's going to be much larger. It's representing 60% of that line length. But now that we've isolated the bad section, it's much easier for us to box select it and just remove that area, because now it has all the edges to help it with that fill operation. So notice we can split all the rounds we'd like, box select the region in the middle, and remove that. And you can always go through afterwards and remove any other rounds that are remaining. So I hope you've seen in this little section how we can select on rounds and remove them, how we can imprint faces, and also how we can detect and remove interference, both automatically and manually. Thank you for watching. Hello. In this section of our CAE class, we're going to focus on repairing models. So I'm going to go to our top left-hand corner and go to Open. So inside of your analysis design session, I'd like you to open up our Stitch folder, and inside should be stitch.scdoc. Now today I'm going to highlight a few areas that are common when importing models from ANSYS that may be corrupt. And I'll show you what those are and show you how to fix them. So you'll notice here there's several surfaces in the structure tree. Now if this happens, the best thing to do is go to the Repair tab. Here's where we have tools specifically designed to help you repair and heal models so you can run an analysis. The three tools that I'll be focusing on will be Stitch, Missing Faces, and Gaps. So the Stitch tool, what it does is it finds surfaces where edges are close or coincident. They're either coincident or within this certain tolerance that we've set up here. Notice it's found one stitchable edge. That means when I click on the red or click the check mark, it'll stitch together into one single surface or one single solid. You notice I'm left with a surface. And what that means is there's probably a few other things that are wrong with our geometry. There's either faces that are entirely missing, which is what missing faces detects, or there's small gaps or slivers in the model. First, we'll search for missing faces. As you can see that it's highlighted one missing face on our part, and we can zoom in to get a better look. That's an entire loop of edges that are open. Notice we have options for this. It'll detect, this determines what it detects, and these determine how it will fix them. It can first try to do a fill, then a patch, or both. Let's look at what fill looks like. What fill does is it tries to extend all the faces around this just like the fill tool. So notice when I click this, it extends this face across and this one up, and the rounds meet up nicely. But I'm going to undo so we can look at patch and how that works. What patch does, it creates a new surface that's there. So just take all the edges and try to fit a best surface it can across that. So notice we have a new face there. And if I undo and do try both, what will happen, it will try to do fill, and if that doesn't work, then could revert to patch. Notice that the fill did work, so it naturally filled that area. But if it's still a surface, that means that there's still gaps in the model. So I'm going to click on gaps to see if we detect anything. And then zoom in to see the problem. So what gaps means is that there's two edges where there should be one. See, these should be one edge, and those should be an edge. But really, there's two on each side. So what gaps does, it finds those areas and places one edge in their place. So it tweaks the model to make that happen. And again, you can always click the red areas or hit the check mark to fix all the problems. So now we're left with one solid which we can now analyze. Let's look at a few other things here. Another important thing for running your analysis will be to search for split edges. What split edges does, if I zoom into one of these areas, it finds edges that should look, you can see it should be one edge that's there, continuous to here, but it's really split into two sections. So this concatenizes them and turns two edges into one. So it'll be really helpful so you have a cleaner analysis. And again, the same thing, I'll click on this area and I'll fix that split edge. Now, another thing to show you in our adjust section where we can merge faces, search for small faces, we can also simplify things. What simplify does is it detects faces that are almost analytic but not quite. For example, I'm going to press S for select, and I'm going to click on that face. We can see that it's a spline. If I go to simplify, it detects that that's a spline, but it knows it should or could almost be a cylinder. So when I click on that area, again, I'm going to hit S for select, it's now fixed that into a cylinder. So it'll provide more analytic geometry, which will speed up analyses. But now another problem is on this top face. You see that there's a spline on one side, a spline on the other, and we have some rounds attached. What I would prefer is to have one planar face on the top of my model. So I'm going to also show you how to manually simplify faces. I'm going to go to the Design tab, and the first thing I'm going to do is fill in this round. So I'm going to double select the round and hit Fill. Now I know I want to replace these two faces with a plane, or a planar face. So the first thing I'm going to do is select on 3 points, because 3 points will make a plane. That'll give me the best approximation, and I'll put a plane in the model. Now that I have that plane there, I'm going to use our Replace tool to replace those two faces with our planar face. So I'm going to Control Select to grab the two faces. I'm going to click our Replace tool. And now I need to click what I want to replace with. So I'm going to click on this plane, which will replace those two faces with our planar face. Now you'll see that it's a plane. And the last thing I'd like to show is that if you remove a few rounds and you'd like to reattach them, you can always go to the Groups tab, which will save all of the round groups you filled. Now, it's usually a good idea to just reattach one or a few rounds at a time. And if I click this button, that same round size is reattached onto the faces. So I hope you've seen in this section how we can repair models with our Stitch, Missing Face, and Gaps tools, and a few other ways we can fix them up by simplify and split edges. Thank you for watching.